Welcome, my friends! You most likely already know that in order to add two fractions, you must have the same denominator. So, for example, we could add 3/7 and 5/7 by simply adding the numerators, since the denominator is 7 for both fractions. Therefore, 3/7 plus 5/7 is equal to 8/7. Well, the same thing applies for rational expressions, where the denominator is the same. For example, we can add 4 over x plus 2 and x over x plus 2 by adding the numerators, since the denominator is x plus 2 for both fractions. These two fractions add to 4 plus x divided by x plus 2. We can still add or subtract fractions even when they have more than one term on the numerator. For example, take 3x minus 5y divided by 7x minus 10x minus 11y divided by 7x. Both terms have a denominator of 7x, meaning we can combine them by subtracting the numerators. Be careful though. The subtraction sign applies to the entire fraction 10x minus 11y over 7x. The best way to think about it is to rewrite the problem as adding the negative of the second term. Now we can apply the negative sign to the numerator and distribute. We have negative 10x plus 11y on the numerator of our second term. Now we can add the two fractions by adding the numerators all under one common denominator of 7x. We have 3x minus 5y plus negative 10x plus 11y. Now we can combine our like terms. 3x plus negative 10x is the same thing as 3x minus 10x, which is just negative 7x. Negative 5y plus 11y is 6y. Our final answer is negative 7x plus 6y divided by 7x. Let's try one where the denominators are not the same. We have negative 7 over 6x plus 5 over 9x. This time our denominators are different. They both have x, but the coefficients on x differ. We can do the exact same thing we would do if the x wasn't there at all, which is to find the least common denominator. You may remember that the least common denominator is just the least common multiple of our denominators, but here we can consider just the constants of 6 and 9. The multiples of 6 are 6, 12, 18, 24, etc., and the multiples of 9 are 9, 18, 27, etc. The smallest number in common to both lists is 18, so that means 18x will be our least common denominator. Now we need to multiply the first fraction by 3 divided by 3, which is just a unique form of the number 1, and won't change the problem at all. That will give us negative 21 divided by 18x, which has the denominator of 18x that we wanted. For the second fraction, we need to multiply by 2 divided by 2. This gives us 10 divided by 18x. Now we can add the two numerators as the denominators are equal. Negative 21 plus 10 is equal to negative 11. So that means that our answer is negative 11 divided by 18x, which can't be reduced. Let's try 7 over x plus 2 plus 6 over x minus 1. In this case, we don't have a common denominator. We consider the denominators x plus 2 and x minus 1 completely different factors that don't have anything in common. Yeah, sure, they both have an x, but when something is added or subtracted to x, that makes things a little bit more complicated. In this case, our least common denominator will just be the product of the two denominators, x minus 1 times x plus 2. The way I think about what to do next is, we need to multiply each term by what we are missing in the least common denominator. For the first term, we are missing an x minus 1 in the denominator, so we multiply by x minus 1 divided by x minus 1. For the second term, we are missing an x plus 2 in the denominator, so we multiply by x plus 2 divided by x plus 2. This will result in two fractions, both of the same denominator of x minus 1 times x plus 2. The numerators are 7 times x minus 1 for the first term, and 6 times x plus 2 for the second term. Let's simplify the numerators by distributing. 7 times x minus 1 is 7x minus 7. 6 times x plus 2 is 6x plus 12. Now we can add the numerators together as the denominators are the same. 7x minus 7 plus 6x plus 12 all over our denominator of x minus 1 times x plus 2. Adding our x terms together, we have 7x plus 6x, which is equal to 13x. Combining our constants, we have negative 7 plus 12, which is equal to positive 5. Our final answer is 13x plus 5 divided by x minus 1 times x plus 2. Okay, let's check out one last problem that has multiple variables. We have 5 over 4 times x squared y minus 3 over 10 times xy to the third. Let's think of the least common denominator in pieces. For our constants, hopefully you can verify that the least common denominator of 4 and 10 is 20. For the x's, the least common denominator is the highest power on x that we see in the two terms, which is x squared. For the y's, the least common denominator is the highest power on y that we see in the two terms, which is y to the third. Now just multiply each term by whatever it takes to get the least common denominator of 20x squared y to the third. For the first term, we need to multiply by a constant of 5 to get 20, as 4 times 5 is equal to 20. We don't need any additional x's as we already have x squared, but we do need 2 additional y's, so we must multiply by 5y squared over 5y squared. For the second term, we need to multiply by a constant of 2 to get 20, and then we need 1 additional x to make x squared. We don't need any additional y's as we already have y to the third, so we must multiply by 2x over 2x. This leaves us with our common denominator of 20x squared y to the third on both terms. For the numerator of the first term, we have 5y squared times 5, which is equal to 25y squared. For the numerator of the second term, we have 3 times 2x, which is equal to 6x. Now we can subtract the numerators and combine to get one fraction of 25y squared minus 6x over 20x squared y to the third. Since we don't have like terms on the numerator, we can't simplify any further, so this is our final answer. Alright my friends, that completes our video relating to adding and subtracting rational expressions.